Okay, so we're going to look at multiplying by complex numbers. So this is the next sort of thing that we'll go into. And to multiply this by complex numbers, we just multiply the real parts. 3 times 4 is 12. There's nothing hard here. 3 times minus 2 is minus 6i. 2 times 4 is plus 8i. And the only thing that's a bit difficult is 2 times minus 2 is minus 4, and you get I squared. So you've just got to remember that this I squared is really minus 1. So you get 12 minus 6i plus 8i, and this becomes plus 4. So 16 plus 2i. And that's all we have to do when we're timesing complex numbers. Now, when we're dividing by complex numbers, so this is 4 minus 2i divided by 3 minus 2i, what we actually do is we multiply by the conjugate. Now, all the conjugate is 3 plus 2i over 3 plus 2i. So all the conjugate is we change this. Now, why do we do this? Because when we multiply this out, what we have is a difference of 2 squares. So on the bottom, we're going to get 3 minus 2i times 3 plus 2i. And that's going to be the first one, which is 9, minus the second one, which is 4i squared. And 4i squared is going to become plus 4. So we get 9 plus 4 on the bottom, or 13. So all I've done there is I've organised what the bottom is. 13. And that's nice. We sort of rationalised the denominator in one sense, or we've made it a real number. And up the top, we're going to get 4 times 3 is 12. 4 times 2i is 8i. No. 2i times 3 is minus 6i, and that is minus 2i times plus 2i is minus 4i squared. And this is exactly what we had before. You get 12 plus 4 is 16, plus 2i. So really we've just got 16 plus 2i. So we haven't changed anything to polar coordinates. So let's look at this next question. And this is probably what Alan will go on to, or what we'll go on to next. Something like this. If we wanted to do 1 plus 3i raised to the power of 6. Now, to do it in this form is really, really tough. So what we're going to do, we're going to change it to polar form. So I've drawn the little picture over here. And so what's the modulus? The modulus is r, which is going to be the square root of x squared, 1 squared plus root 3 squared. Okay, 1 squared plus root 3 squared, which equals the square root of 1 plus 3, which is the square root of 4, which equals 2. So the modulus is 2. And what is the angle? The angle here is theta. So it's going to be tan. So theta equals tan the minus 1 of y over x. Now, I know that is 60 degrees. It's one of our ones. And let's just change that to, if pi equals 180, therefore 60 is going to be equal to pi over 3. So now the way we can write that in polar coordinates is we're going to write it as 2 cis theta. And what that really means is it just 2 cos pi over 3 plus 2i sine pi over 3. But sometimes you'll see it as 2 cis theta instead of 2 cos pi over 3 plus 2i sine pi over 3. So now we want to raise that to the power of 6. These two things are exactly the same. One is in Cartesian, one is in polar. Now, by DeMovires theorem, what this becomes is if you have r cis theta to the power of some n, what that becomes is r to the power of n cis n theta. And that's really, really easy. So that's DeMovires theorem, which we will get onto, I'm sure. So it just becomes this to the power of 6 just becomes 2 to the power of 6 cis 6 times pi over 3. 2 to the power of 6 is 64. Cis 2 pi. So actually that's really, really nice. It falls out really, really easy. If you think about it, where is 2 pi? 2 pi is around here. So this just equals 64. Okay, hopefully that's cleared up, and that will show us what DeMovires theorem is when we talk about that next lecture. Thanks.